Hi everyone, I hope you are all doing well. This week we will study biomedical knowledge resource and information retrieval. So let's see the lecture's agenda. So our objectives are from this topic. We will start with enumerating the basic biomedical and health knowledge resources. We will see what kind of resources available and we will describe the major approaches used for indexing knowledge based content. Now, several terms: what is indexing, what is the knowledge based content system, approaches. So, this we will see in this part. Thirdly, we will see that how we can apply advanced knowledge share searching techniques on major biomedical knowledge resources. For example, I will show with an example that how when you go on pubmed.org, how you can advance feature just like and or Boolean search for information retrieval. We will also discuss the major result of information retrieval evaluation, like if we have to know that whether which search engine is better, what are the criteria, and how we measure the overall information retrieval rate of the search engines. And lastly, we will discuss uh, I will show you the future directions, uh, what's going on currently in the information retrieval domain. We discussed about information retrieval in brief in our previous classes, but this lecture is specifically focusing on biomedical information retrieval, as this is a major part of the biomedical and health informatics course. So starting with the definition, information retrieval, as it names just information retrieval, accessing of information, right? And what comes to your mind? I mean, to my mind, it directly comes to Google, or in the biomedical, it comes to the PubMed. So these are the search engines. We call that search engines. Technically, we also call them the information retrieval engines. Uh, so information retrieval is a is an approach help us in finding material which is mostly in unstructured in nature and available in abundance on the internet. For example, if you go to the Google Scholar and over there you type COVID, you will see several research papers, articles will appear over there. So this is the process of the information retrieval based on some keyword or some information which we provide them. And unstructured mean the data over there is mainly in the text format, and that data is not in mainly aligned, is not in a tabular format or aligned with a linking with the vocabularies or biomedical vocabularies. So now if you see the at present, we not only have the text data, we also have the image data, we have some videos data and some special data just like the chemical structure. So the information retrieval process is not limited with the textual information retrieval. It's more than that now. So that's the definition and background of the information retrieval. Now, how does this process work? I think so. I have shown you this diagram earlier, but you see when you will go there, for example, let me take an example, then I will explain this process like query, metadata, content, and search engine. No, the search engine part, we have this search engine, just say we are on the Google or we are on PubMed, right? Let's take the same example of the COVID. Now we'll enter the COVID over there. Now, when we enter the COVID over there, the engine, the information retrieval, I'm just putting this with a gear sign, with an engine, which is at behind, which is the intelligent algorithms. They basically understand the content. What is COVID is? COVID is the type of disease, like which is also similar to the or the same as the coronavirus, and which is also a type of some flu-like or influenza type disease. So that information is provided by the search engine that we will call the metadata. Right? That we will call the metadata. And when the query, this is the query, your query plus metadata, when we'll send that into a retrieval engine, this will brings you the document. I gave the similar examples to the library earlier, like when you go to the library and ask to the librarian that I'm looking for a book in metaphysics, right? Now the librarian will say, okay, you first go to the science section and then look into the physics section, and then there would be first there would, for example, just like in a hierarchical, science section, physics section, then you will go to the metaphysics section, right? So this is the metadata as well. This is the information which helps to understand information. So in short, the overall goal of the information retrieval is the process to find the contents that meets the personal information need. And this is a search engine, just like the Google search engine. You need a query and some metadata, data about the data, and this query and metadata helps to index that. Index, in physical libraries, we have the indexing, we have some name tags over there, or we have some, the on top of that science section, or we can say this is an art section. We have different oils, and with they have different section number, and the information that could help us to find the related book. So this is how the information retrieval process works. Now, this is a very, very good example, iterative examples. When you will go over there, you will see it will giving you an example of coffee, right? Or you can even type that, for example, you can type information about the iPhone, and it will show you that how the Google search engine works, how it will take the coffee keyword, and then it will find the how it index at backend, and how then it will retrieve us or give us the related documents. So this is very, very important to learn the concept of information retrieval. So please spend at least 3 to 4 minutes and with different queries to see that how the search engine works. When you are done with that, then you can resume this video again and start from here. Now, I believe that with that, you have the understanding about the information retrieval, how the search engine process work. Now, let's see, understand the concept of knowledge base information. What is mean of the knowledge base information, and what type of information we have available, or what type of knowledge we have available. So basically, the knowledge base system, we categorize that into two parts. One is the primary knowledge, and second one is the secondary knowledge. Primary knowledge, the example is based on the information which is originally research, journal, books. For example, at this time, what you guys are doing as your class project, you are writing a review paper, right? So what you do that, you will find the related research papers, research paper 1, research paper 2, and so on. And then you will take that paper, you will compare, contrast, and write then a very good, the summary, and that we will call that a review paper, right? So now these research paper, original research or books, whatever you are consulting, are called the primary knowledge or primary source. And whatever come out of that, that will call the, just like the review articles, that we refer to as the secondary source. Now, So the primary resource are the main resource, just like journals, books, reports, and other resources, and same as the secondary resources are based on the information consist of the writing, such as the reviews, condenses, synthesis of the primary literature. The most common example is the review article, which you are working on and read several review papers already and have some experience. All right. Now, publications of knowledge-based information. At this time, uh, around 100% paper, the journals, they have their electronic version in some form. Either they have a completely everything they put on web page, or they have saved as a PDF. Alongside, still there are journals which publish the hard copy of the journals, but most of the journals are turned to the online version. So, but although they have turned themselves and online, still, the concept, just like we have the editor, proofreader, distributor, still they are keeping that concept with them. Uh, though the nature of the things has been completely changed. For example, previously we we used to have, and even now we have the librarian, a person who help us to find the book. We also have the library interface, web interface, where we can go over there, type the book, and can find the books ourselves. So that's not a that's kind of an additional tool or help available in the form of the web tool. However, there is still value added by the publisher, such as hiring and managing editorial staff to produce journals and managing the peer review process. Still, they kept the old titles. We see editor of the journal, editor of the newspaper, publisher, distributor. Still, they are there, but the nature of the job now has changed from the paper world to a digital world now. Now let's discuss publishing cost and open access. Probably you read some word open access or heard the word of the open access. So what is the concept, or what's the motive behind to have or provide the articles open access? The basic principle of open access publishing is that the authors and other institutions pay the cost of productions and manuscript upfront after they are accepted through the peer review process. Now, what happens? Scientists work on something, right? So they work on some biotask, and then they produce some result out of that, and then they write paper and submit to a journal, right? After the acceptance, the papers are available now online. Probably you have noticed that when you go to download some paper, they say you don't have access that. So those type of paper, we call that closed access. And the papers where you can openly download without paying any fee, without paying any subscription, that are called the open access. And most of the journals is biomedical. They offer to authors, if they want to make their articles open access, they have to pay some upfront fee. Usually, as most of the projects are run by the federal funding, so they have so the federal funding covers the cost of the publication. Usually they have the $1,500 to $3,000 charges, and when you will pay them, then all the journals articles will be available publicly free for some forever, some with like the licensing like up to 4 year, 5 year, 10 year. Then you have to pay again the subscription fee for that. After the paper is published, it becomes freely available to the web. The most of the research is usually funded, as I explained. Some examples you can get, if you can go to the Biomed Central, or you can go PLOS.org and just try to search any. For example, you can just search like a hay fever, right? Or maybe you can search with a cancer and try to open a few papers. You will see that most of the papers, maybe you will see this sign, and if with this sign, most of the papers are freely available to download. All right. Now, information content. When we are discussing about the papers, open accessing, we should also have some idea about the information content. What kind of the information usually available on the biomedical information retrieval systems? So the biomedical information, we can classify them, the information itself, into four categories. For example, categories are the bibliographic, full text content, then we have annotated contents, then we have the aggregated contents. Now, for example, when you go to the Medline or PubMed, right, when you go to the pubmed.org and you type the word just fever, or you say eye disease, right, and it will give you a list of the papers. Not all the papers are hosted by them. Hosted mean they are not all the papers are stored or saved on the server of NIH. So they basically, when you click on them, it will take you to another website where you can download or see the content. So that's the example of the bibliographic kind of content. Then full text content. A large component of this content consists of online version of the books and periodicals. As already noted, most traditional paper-based medical literature from the textbook journal is now available electronically. So with that, full text content, other than or in addition to the bibliographic information, they also provide the full content. When you click on them, it will show you the entire paper, article, or book. The example you can find on when you go to the Medline, and you can search with any keyword, you will see both type of. So Medline will provide you the bibliographic type of contents always as the full text contents. Okay, now let's move on to the annotated content. Annotated mean you know that this is what I am doing. This is the annotation, right? So I'm saying the so on the web variant, you will see that there are some web interfaces where it allows to the people, it allows to the reader to annotate that, add some comments, right, to either to endorse the ideas or to refute the ideas, right? So that these resources usually not stored as if freestanding web pages, but instead of housing database management system. So it's depend on, they are available as a web form, but maybe when you first time will open that, when you will see the document clear without annotation, and after that when you will add the annotation, they will keep your annotations, and when you will come back you will see your annotations. They also have the option if you would like to see the others people's annotation. For example, if others people they have read this document and you would like to see the annotation, you can see over there. I think the another example you can see on the medium.com. If you go on the medium.com, and there are where the people publish the articles, you will see that most of the peoples they have annotated the others people document. So that's an example of that. Now there are some resources just like Medline Plus. They not only just provide the papers, but they also add some information just like the images, figures, the videos about the articles. For example, aggregated content has been developed all types of user, consumer to the clinicians, probably largest aggregated consumer information on the Medline Plus. For example, if you just type maybe the breast cancer, or you can type any eye disease, the contents are probably not understandable in the technical language to all the people, but if they go just PubMed and search that, because the PubMed will only give them the research articles, right? But if you would like to see the journal content along with the research content and with some graphics, videos, then how you can do that? So the Medline Plus is an example which can provide you an aggregated form of the information, and so this is how we categorize the different types of the information. So first one is a bibliographic, full text content, then annotated contents, and the aggregated contents. All right. No, you can write whatever on your notes as you are preparing. Now we are moving towards the indexing. Now, what is indexing? Indexing is cataloging, like just like I gave the example that how they index that. For example, in the libraries at this time, they have different oils, different shelves. So the shelf, right? And then they have the science, fiction, art, and you get, as a person, you go over there, right? You walk through these sections and can find the book of your choice. Now, this indexing, when the library is limited, they have like in 2 buildings, 3 buildings. But when we have, as we are discussing the digital content, you see millions of contents are available. Then how it would be possible for them to index? So what they do that they use the mix kind of technique, both with the like they use both the automated way and also the manual way. So let's see what indexing is first, like how we define formally. So indexing is the process of assigning in the metadata to content to facilitate its retrieval. Most modern commercial content is indexed in 2 ways. No, the indexing is simply, we can say that we attach the metadata just like, so these are the bookshelves. So the science, fiction, art, so these are basically, we are categorizing them and indexing them. And so manually, I gave you the example where human indexer usually using a controlled terminology, assign indexing terms and attributes to the documents. We will see about control terminology momentarily. What are the control terminologies are, especially in the medical. Now, automated indexing. You see that this is the case of the digital, where we have millions of documents, like around 1 million documents every month are being added on the internet. Then we have special programs, computer softwares that understand the NLP, natural language processing, and automatically index them, categorize them at their backend. And with that procedure, it helps the search engines to retrieve that document. So that's the part of the automated indexing. The people with have a computer science background, they will better understand this is a complete field of the indexing, and the people are working in the NLP domain, and their main job is to understand the contents and then use those contents, adding the semantic information and using that information for different purposes. Now, controlled vocabularies. Controlled vocabularies, a controlled terminology, contains a set of terms that can be applied to tasks such as indexing. So ontology, we can say, is an example of the controlled vocabulary. You see the ontology of like the cancer, in the cancer ontology, they have all the related vocabularies, all the related terminologies about cancer. And why we are saying the related vocabularies about the cancer, and why we consider that these are controlled vocabularies? Because most of these vocabularies are bag of words, or the list of vocabularies are prepared by the domain experts, and they say this is the better, proper way to use that. Now, for example, let me give you an example of the coronavirus. You see, when it came, the people were calling that either coronavirus, some COVID. No, you see, at this time, the COVID is more popular because now they have uh, standardized the COVID-19 a virus strain, right? And we people understand that the coronavirus is COVID-19, the COVID-19 is the coronavirus. So so when the terminology defines the term, it's called vocabularies. Now we can say that COVID-19 is now become a vocabulary. So thesaurus similar to the ontology, where the terminology contains variant or synonyms of the terms, and it's also called the thesaurus. The difference between ontology and thesaurus are ontologies, they use rules, some logical rules, and are more formally designed. Thesaurus are loosely coupled. They are not designed or in a way which is kind of the rigid. Ontologies, on the other hand, are very rigid in their structure. You cannot add more information under one category unless all the parties are agreed. Where the thesaurus, you have some leverage or to add some more ontology. So here, if you go to this article, I found that very interesting, and it's clearly defining the concepts of ontologies, vocabularies, and thesaurus, and the difference between them. So please spend time on that, learning about controlled vocabularies. And when you are done with that, then you can resume the slides and can go to the controlled vocabularies structure. When we say the controlled vocabularies, now what types of controlled vocabularies are available? So a controlled terminology usually contain a list of the terms that are standard form of concept, and we usually divide that or categorize that. A controlled terminology could be a hierarchical type. A controlled terminology could be a synonym type. A controlled vocabulary could be a related type. Now, COVID-19 almost equal to the corona, right? Corona. So we can say that the terms are synonyms, allowing an indexer to search that. So these are, but the COVID-19 or corona is not equal to flu, but it's related to, it's a flu kind of, it's a respiratory disease. It's not is equal to respiratory disease. It's not it's not the syntactically, and is not equal to COVID-19, not equal to respiratory disease, but semantically it's not the synonym, it's a related. So we can say these two examples will help you to understand the synonym and related. Now, for the hierarchical information, as I gave the example of hierarchical, so the information is arranged where I gave the example. I think I gave the example here. Where I was giving the example about science, then physics, then metaphysics. So basically, it creates a hierarchy. So there are terminologies where we have the main, just like we have the then main. Just consider a type of pathogen. We have the pathogens, right? And then we have different types of pathogens. Then we have fungi, we have then bacterium, then we have the virus, then we have the different types of viruses, different types of bacteria, then different types of fungus. So this is the type of the concept that we organize that in hierarchically. I will give you the more example with the mesh term, and then you will get the complete idea about the hierarchical information. We will come to this slide after seeing the next slide. So this is the mesh. It's a very famous medical subject heading, vocabulary ontology. So the mesh terminology, in a mesh terminology or in a mesh vocabulary, they're associated data and supported by the document